My name's Robert Day. I'm based in California. Unfortunately, I just looked at my watch and it's 1 o'clock in the morning in California time, so I'm going to have to try and keep myself awake and you. I work for ARM as my day job, but I'm also one of ARM's governing body representatives on SOAFEE, and I've been with SOAFEE since the start, which was about 2.5 years ago. So I'm going to give you an update on what we've been up to and what we're doing within SOAFEE. And I'll also be at the networking event later on if you want to talk in more detail. This is sort of just an opening slide as to what we're seeing in the market trends in automotive with more autonomous features, electrification, a different user experience. It comes back to some of the discussion we've had about the car being what the consumers want it to be. A lot more software in the vehicle, hence the term software-defined vehicle, and also a lot more demand for AI computing to actually power all this stuff. So what that does is it offers new challenges, but also opportunities for the automotive and the software industry to kind of come together to put together new solutions. And that's what we are trying to do in the SOAFEE initiative. So this slide hasn't changed since we started SOAFEE. So it's really looking at what is SOAFEE? What is SOAFEE trying to do? So firstly, it is an industry initiative. It was founded by, you'll see the kind of the governing body, which was really the founding members of SOAFEE, to really kind of look at how we can bring techniques and methodologies from the established cloud-native world and bring it over to automotive workloads. And what that means is that we're defining an architecture. What we're really trying to say is how do we bring these over from the cloud, but knowing that the final deployment is not going to be a cloud instance, it's going to be a vehicle. And that has real time, that has safety criticality and mixed criticality built into it. So what does that mean and how do we achieve it? The last thing is, for any initiative to really kind of get any momentum, you need to have the ability for people to try your technologies, your methodologies out. And so we also have an open source reference implementation of SOAFEE. The goal of SOAFEE is not to produce open source. The goal of SOAFEE is to actually start bringing standards that have been typically in the cloud world to understand automotive. And you'll see what some of those are in a little bit. So this is the SOAFEE high-level block diagram, kind of really showing what we're doing. So at the top there, you can see we've got the cloud. And in the cloud, we essentially have, typical cloud-native CI/CD methodologies, DevOps, etc. And you can see that we have a virtual compute environment. I'll talk about that a little bit later on. But there's also this concept of containers, containerized applications, microservices. I heard somebody else talking about microservices earlier on. That's all part of SOAFEE's kind of purview. And so you'll also see we've got orchestration. So that's another cloud-native technology that we're trying to bring over to the automotive world. But that's interesting because, again, the orchestrator has to know that what it's actually going to be kind of deploying is not a cloud instance, but is a mission-critical edge device. And so you can see the bottom part of this is where you get to deployment. And that's where, again, you have the similar things. You have containers, you have orchestration, we have the same OSs, but now we're really running on real hardware, not virtual hardware in the cloud. And a lot of this, what's going to make SOAFEE work is the fact that we now have parity between the processors that are running cloud instances and what goes in the vehicle. And we'll talk a little bit more about that later on. So here's the membership of SOAFEE. As you can see on the bottom left, they're sort of majority of the founding members. And when we started SOAFEE, we wanted to have expertise from automotive, so you've got tier ones, OEMs. We've also got software expertise. So we have Red Hat, we have SUSE, and we have AWS from a cloud perspective. And it was really this group of individuals, companies about 2.5 years ago, that really defined the slide I just showed you, which shows the architecture of SOAFEE. We now have a lot more members. We have a lot of working group members, and I'll give you a bit of a demographic of that on the next slide. You can see from the member type, we go across CSPs, OSPs, ISVs, OEMs, Tier 1s, system integrators. And we've got really quite a broad set of expertise. You can see there's a big box that says other there. That's where people didn't quite fit into these other groups, so I lumped them into other. I do a better job of that. But you can see, we've got automotive industry experts, and we've got software experts, and we've got people that will do the integration. I actually want to point out a really good example of that. If you go outside, you'll see the Tata Technologies booth. And Tata Technologies are a system integrator. They've actually been taking SOAFEE, AutoSAR, Covesa, and Eclipse SDV and bringing that all together in a demo. So it's really quite a powerful view of how these things can come together. But it also demonstrates the cloud native and cloud communication. From where are our members? We've pretty much got global representation now. So you can see there's still a big chunk of companies in the US. That's the software companies, the OSPs and the ISVs. But we have good representation pretty much from all the automotive regions out there. We have China, we have Japan, we have Germany, we have the US, we have Korea. So we've really got good representation from companies around the globe. So, we've been around for 2.5 years, about the same length of time as the Eclipse SDV project. And we now have over 120 members. I think for each of us, we like to say how many members we've got. From our perspective, we wanted to have expertise, as you've just seen, across the globe and across the different types of organizations. Because we believe in SOAFEE, it's going to be collaborative across people with lots of different levels of expertise, including functional safety, including security, including real-time systems. What's interesting is, we've had our members, and you'll see in a minute, we like Eclipse SDV, have blueprints that our members are getting involved in. What's been a bit of an eye-opener is we've been going to events talking about SOAFEE, we've had symposiums and seminars on SOAFEE. It's amazing what the members have done on their own without even telling us. So we've got lots of collaborations going between different members, putting together different kind of demonstrators and POCs, and really looking at how they can use the SOAFEE architecture and also the open source reference implementation to kind of get people started quickly. Now, what we're doing this year is we're going to this phase of implementation. We've got our membership in place, we've got kind of our roadmap in place. Now it's down to implementing some of the key aspects that SOAFEE is trying to deliver on. And that's really looking at mixed critical compute systems and how you can develop them, orchestrate them, deploy them to the vehicle. And so what we're doing is we're trying to use, and I'm getting to blueprints next, I'm kind of jumping the gun a bit here. We're going to try and use one or two of the existing SOAFEE blueprints to showcase how you can do mixed criticality, because that's the key part of SOAFEE. So SOAFEE has this notion of a blueprint, and rather like the Eclipse SDV one, it's basically applications and workflows to show examples of how you can use a SOAFEE environment to develop in the cloud and then deploy to the vehicle. But also, not just develop in the cloud, but actually test in the cloud, use virtual environments in the cloud. So a SOAFEE blueprint is essentially a workload. It doesn't have to be open source. It could actually be a proprietary workload too. But we want to take examples across the automotive world. So having things like an IVI blueprint, having a connected car, having also autonomous or AD blueprint, or ADAS blueprint is kind of important because it then showcases the different types of function that you'll develop as a software-defined function can be developed using a SOAFEE environment. So, the first blueprint we did, we worked with the AutoWare Foundation. So AutoWare has an open source autonomous stack, and interestingly enough, when we started, the auto-aware stack was a big monolithic thing. That's how it was developed, that's how it's being utilised. And what we wanted to prove out with SOAFEE is, well, can we break that down into these containerized, let's call them microservices or functions? Because the whole goal with SOAFEE is if you can break down your software applications, it's easier to update it. It's easier to do OTA for it. And so we thought, okay, we'll do that with an autonomous drive stack. And that's a nice big piece of software. So we managed to do that, we broke it down, we ran it on the SOAFEE open source reference implementation called E1. Not a marketing term, it's an engineering term. And then basically ran it on a piece of example hardware that could be used as a central compute or AD compute. So in 2023, we did the kind of first real demonstration of this. And we actually ran it on real hardware. But one of the things that we did, is we looked at this and said, well, wait a minute. The three boxes on your left will fit on an app. They'll run on an application, a big, server-class application processor. The stuff on the left, really, your right, the vehicle interface really has to run in a safety critical system. It's doing the actuation of the vehicle. And so what we decided to do was run all of the stuff that was on your left, three boxes on your left, on a regular big server class processor. But we moved the control feature over to a different operating system and a different safety processor. So on the left-hand side, we have something called a Neoverse, which is an ARM server class. On the right-hand side, it's Cortex-R, which is our real-time safety processor. And that's what's going to go into safety islands and safety systems. Okay, that was last year. So real hardware, big server box, small real-time processing box, communicating over Ethernet using DBS, because that's the communication vehicle they use. Fast forward to this year. So in Embedded World this year, we took essentially the same application. Looks pretty similar, doesn't it? But instead of running on a real hardware, we ran it in the cloud on virtual prototyping. So we have a virtual prototype of the R82, and we actually ran it directly on the AWS Graviton 3 in the cloud. And so we're basically showcasing that same thing that was running on real hardware last year, we've now got it running on virtual prototyping now. And there's a kind of goal to this when it comes to software development for the software-defined vehicle. And this is what we're doing for this year. So it looks pretty similar again, doesn't it? Except we're now running everything in a true virtual prototype. So there's a company called Corellium that makes these fast virtual prototyping environments. They communicate over shared memory versus Ethernet. Okay, still TDS, still the same applications. And what we're doing is we're turning this into a reference implementation we call RD1AE. And this is going to be a way that you can look at what hardware is likely to be coming in, let's say, 3 or 4 years' time. But we're going to start showing you how you can develop. And we're using this OpenAD kit, the AutoAware, because it is a big piece of software. And we're showing how you can move things around, break things down, how you can develop and run in the cloud. So that's kind of a lot of what we're up to right now, is proving out that you can run these applications in a mixed critical environment. However, we still need to do some work to make sure that the orchestration part, the bit that's in the cloud, knows about where it's going. So all that stuff I've just shown you, we've got to now make sure that the orchestrator knows, well, this is what my system looks like. I've got real-time processors here, I've maybe got some AI over there, I've got some big processors here, and I've broken my application into these containers. How does this all come together? So there's a few concepts that we're bringing in. Firstly, we want to show how you can implement heterogeneous containers. I already heard this in one of the AutoStar discussions today about having containers running in the AutoStar environment, We also want to have it running in a real-time environment. Okay? So we've got to define how that works, and I'll show you the kind of the roadmap to this. We also really, for the actual deployment of the vehicle, we're having these containers doing different things, potentially running on different processes. They need to communicate with each other, but they need to be deterministic. And so we're bringing now time-sensitive networking into containers. And you'll see in a minute that we're trying to do this through standards, through the OCI standards, the bringing the real-time, the safety, and the mixed criticality into that. And then the last part of this with the orchestration is, if you look at the Kubernetes namespace, it's enormous. We don't need all of that for automotive, so what we're trying to do is define what's required for automotive. Now, this is not something any one company can really do. There's a lot of people looking at orchestration, containers, and that sort of stuff. We want to do this as an industry, okay? And we want to do it going back into the defined standards for these technologies. So this is our roadmap. Okay, I'm not going to go into all the details of it. Essentially, we're using the blueprint at the top because that's a really good mixed critical environment, an example. We've got our open source reference implementation, which we will keep updating as we go through this. And then we have a bunch of different projects that we're bringing into this mixed critical orchestration. So the first one is there's a working group that's looking at microkernel OCI. That's how we can bring this over onto the real-time processor. We're working with LG on their Piccolo blueprint, along with the Eclipse SDV Blue Chai from Red Hat, and bringing those two together to bring the orchestration in. We're doing this KAS allow list, and then we're bringing TSN in. So there's no dates on this because we're still working out what each of these looks like. And it might be things get shifted around. We're really looking to telling the working groups to figure out kind of when these things will become available. But this is our nominal roadmap to get to mixed critical orchestration. We're shooting for this to be a 2025 thing. So we're at it right now. Work groups are defining what they're doing, trying to bring the relevant, identifying and bringing the relevant technologies in, looking at the different standards and what we need to do to them. So this eventually is kind of going to look like from a block diagram. Again, you can see the Cortex-R and the Cortex-A, that's the application of the real-time processors. You can see we're bringing hypervisors, Linuxes, but also real-time operating systems. We need the automotive real-time operating systems. The SOAFEE community has essentially all the AutoSAR implementations. It also has a lot of the real-time operating system implementations. Because we know we're not going to do this just from an open source reference implementation. We need to have the operating systems, the hypervisors, the AutoSAR implementations that people are going to go into vehicles. It just happens to be developed and deployed in a SOAFEE environment. I showed this at the AOC last year, and I was looking at it thinking, yeah, I don't think this has really changed as far as how we bring AutoSAR into SOAFEE. And you can see, I don't know talk later, you can see on your right-hand side, that's the real-time, that's the safety system, that's running AutoSAR Classic. And then on the application processor, we can have general purpose operating systems, we can have AutoSAR, we can have RTOS. It's all kind of working together to have the different workloads and different levels of safety criticality running in the system. So this, I think, is really quite a good example of how SOAFEE and AutoSAR can kind of come together for those mixed critical applications. As you can see, this is all about mixed criticality. It's what we really care about in SOAFEE. This is the last little bit. So one of the other things we've been doing is figuring out how we can have SOAFEE at scale, i.e. how can we scale this out so that more and more people in the industry can work together, can collaborate, developing the software-defined vehicle. This is the automotive stack. I'm not going to go into it in too much detail. But there is a key part of this, which is the virtual prototype. For us to be able to scale that out, there isn't enough hardware in the world for all the engineers in the world to be running on real hardware. So we have to take advantage of real-time. Virtual prototyping, we have to take advantage of cloud instances. And what we're hoping is by doing this, we're going to embrace the full shift left of software. So rather than, you know, the automotive development being a sort of sequential thing where you do your hardware design, software development, then your system integration, we're going to bring software earlier. And with the virtual prototyping, we're going to allow you to develop on processors or processor architectures that don't exist in silicon right now. So you can do stuff that's going to be 3 years out as far as silicon. And we can do that because we're creating these virtual prototypes of today's most recent IP as it's going into silicon. And as you can see, I've already mentioned the RD1, which is our, basically it's our platform for mixed criticality to showcase how you real-time safety islands, application processes all together, okay? We have these virtual platforms. Now, as ARM, we do some virtual prototypes. Well, what we found is that the EDA community, the Siemens EDA, Cadence, and there's also a company called Corellium, are really good at doing these virtual prototypes, and we're taking advantage of that relationship. And as you saw a few slides back, where I showed the RD1 with the OpenAD kit, that was running in a Corellium model, and that runs today. And then the other part of this is having CI/CD, you know, cloud native and the services to go around it. This was the SOAFEE roadmap that I showed you a bit earlier. But the SOAFEE.next is really what came this year. We brought this technology in so that you can actually develop at scale using a SOAFEE environment. And we're just going to continue this. This is what's going 2024 into 2025. And as you can see, here's another block diagram, essentially showing the same thing, except I've switched real-time and not real-time over. But essentially, you can see we've got all of the stuff on the right-hand side with our blueprints, we have our safety islands, and the RD1 is the platform that this is going to be developed on and we'll have virtual prototypes of. And you can see there's a kind of continuum here for your software development. So on the left-hand side, you can take advantage of cloud instances, the AWS Graviton cloud instances. They're ARM-based. You can run directly on these things. There's QNX ports for it, there's Linux ports for it, so you can actually run your applications directly on it. However, that's not really mimicking the true virtual prototype of what's going to happen, because it doesn't have any safety concepts in it. So the next step, the virtual platform, is to bring safety islands into it, the mixed criticality. And then finally, you'll actually get your silicon, and that's where you can then run. The idea is that your software shouldn't change as you go through this. You should be able to develop a lot of your software at scale in the cloud before you get anywhere near that right-hand side, which is the hardware. So, last slide. If this all sounds interesting, and you're not SOAFEE members already, come see me. Or, if you don't want to come see me, you can go online, you can go to our website, you can look at our Slack channel. And, you know, this is something that, you know, really does have some interesting momentum in the industry. And so we're encouraging people to come in, get involved. We've got a good roadmap now. We know what we're trying to achieve. So as new companies come on board, we've got a good idea as to how they can contribute and how they can fit in. In fact, I'm 2 minutes early, I think. Yay.
Thank you.
Thank you.